AA batteries. When they're dead, they usually get forgotten in a drawer or thrown away like they have no value left. But inside, there's still metal, still potential, if you know how to use it. And in this video, I'm going to turn an old AA battery into a working part of a DIY mini welding machine. The whole battery looks like this, but all we really need is a core inside. The outer casing is mainly for insulation and protection. It doesn't directly take part in producing electrical current inside a standard AA battery. The central core is typically a conductive metal rod, designed to collect and transfer electrons, generated by the chemical reactions within the cell. From a physical perspective, this core has a solid structure, stable electrical conductivity, and heat tolerance suitable for low-power applications. However, once the core is removed from the battery, it cannot be used immediately. To turn it into a DIY soldering tip, the core must go through a reshaping process. Specifically, one end of the core is ground down to a sharp point. This tip isn't shaped randomly. It's formed to resemble the geometry and angle of a real drill bit, allowing heat to concentrate at a single point and improving precision during soldering. After thorough cleaning and careful shaping, the battery core can finally serve its new role as a simple yet effective DIY soldering tip, well suited for small, precise solder joints in compact DIY projects. And that's it, a DIY soldering tip made from an AA battery core. Looking at it now, not bad at all, right? After finishing the soldering tip, I move on to building the heating head for this mini welding device, using a spark plug and a short length of single core wire. At this stage, I apply a purpose-driven short connection method, not to bypass functionality, but to fully utilize the electrical and thermal properties of metal from a basic electrical standpoint. When two conductive points are directly connected, current flows along the path of least resistance. But during that flow, every metal component involved in the circuit becomes part of the heat-generating system. A spark plug is especially suitable for this role. It's designed to handle high current, withstand extreme temperatures, and features a clearly separated metal structure between the central electrode and the outer threaded body. Specifically, one end of the wire is connected to the central threaded terminal of the spark plug, which serves as a current entry point. The other end of the wire is connected directly to the outer threaded metal body, forming a closed conductive loop. When current passes through this configuration, it doesn't simply travel from point A to point B. Instead, it spreads throughout the entire metal structure of the spark plug. This distribution causes the spark plug to heat up in a controlled and uniform manner, concentrating thermal energy at the intended welding point. Through this short connection approach, the spark plug effectively becomes an active thermal mass, allowing for rapid heat transfer, minimal energy loss, and a form factor well suited for a compact mini welding device. To connect the threaded end of the spark plug with the DIY soldering tip, I don't need to fabricate a new custom part. Here, I already have a standard electrical terminal block. What I'm interested in isn't the plastic housing, but the metal connector inside. This metal connector is designed to clamp firmly and conduct electricity between wires. By nature, it provides both mechanical stability and reliable electrical contact. By using this metal insert as an intermediate coupling, The DIY soldering tip and the spark plug thread are joined directly metal to metal, creating a solid connection that allows current to flow smoothly and consistently. Before installing the soldering tip, I'm going to wire everything up first. If you're wondering why I'm doing this step now, there's really nothing special about it. I'm just changing the order a bit to keep things from getting repetitive. Here, I'm connecting this red wire so it runs from a positive terminal of the power source to the ground contact of the spark plug, basically setting up the electrical path before the full assembly. If you don't want to get shocked while using electricity, just make sure you wrap electrical tape properly around the connection points. It only takes a moment, but it makes working with electricity a lot safer. To connect this welding device to the power source, a crocodile clip is pretty much essential. So here I'm attaching it to the other end of the wire. It's quick, convenient, and makes it easy to disconnect or adjust later on. With the previous steps already done, all that's left now is to install the DIY soldering tip into the remaining port of the connector. Using a small adjustable wrench as a handle for this DIY mini welding tool actually works pretty well. It feels solid in the hand and gives good control. I've wrapped electrical tape around the handle too, so holding it while soldering feels safe and I don't have to worry about electric shock. Protecting the electrical connections is always a top priority. So here I'm securing part of the wire to the handle of the wrench. That way, when I'm actually using it, the cable won't get in the way, and the connection points are less likely to be stressed or accidentally pulled. Of course, when working with a power source, you can't ignore the negative terminal. So here I'm using a single core wire with 2 crocodile clips attached at both ends, making it quick and convenient to connect to the power supply whenever needed. To power this setup, I'm using a removable battery from a cordless drill, which is familiar and very convenient to work with in the workshop. To make the connection even easier, I've added 2 metal rings to the positive and negative terminals of the battery. So when hooking it up to the DIY soldering device, everything goes together quickly without having to struggle with loose wires or clips. No need to worry. The AA battery core is just a bit damp. Once it heats up and dries, it works just fine for this testing step. I'm only doing 2 small tests, and honestly, there's nothing too challenging for this DIY soldering device. Still, the best way to judge it is to watch until the end. Then you can see for yourself how this mini homemade soldering tool really performs. So from an AA battery that would normally be thrown away, with a few simple steps and some basic assembly, a DIY mini soldering tool is brought to life and works as expected. It's not flashy, but it's functional, understandable, and most importantly, built by your own hands. To me, that's what DIY is really about, using what you have and turning it into something genuinely useful.